Hi everyone, great to be here. Thanks for joining us today. I hope it will be really interesting for you and it will be very useful for you. So before going into the details, I will move it maybe a little bit here. Before the start, just a couple of words about myself. I joined Wix about 9 years ago, and during my career at Wix, I worked in different projects. First, I started in automation infrastructure team, where we were building an automation framework for our QAs. After some counting, I found there are around 40 projects built upon this framework, and we have more than 5,000 tests. So quite a lot. Later, I switched to another team. It's a velocity infrastructure team. And there we were working on the internal projects to increase our development velocity. We've built really interesting projects that helped us in our day-to-day work. And a couple of years ago, I switched to the data infrastructure team. In this team, we are working on different projects with big data to collect data, to validate this data, compact and save in our storages. After gathering some statistics, we found out that we collect up to 11 terabytes of raw data per day. Everything is per day. And today I want to tell you about the event sourcing and CQRS. It is the design patterns that we implemented in one of our projects in data infrastructure. So first, I'll start with a quick description of the domain problem that we had a couple of years ago. We implemented this solution to this project, to this problem in this particular project. I'll describe the project, of course. Right now, this project is in the support and maintenance mode. I'm the owner of this project. And I'm working on new features and maybe some bug fixes and so on. Of course, I'll talk about the design patterns that we used during the implementation of this project. Just a quick overview. It's not a theoretical lecture, so don't worry. And right after it, I'll show you the implementation. At least one user flow, big user flow, how it works and how it works internally. And during the development, we faced with some questions and we did some solutions. So I describe you also our solutions for these questions or issues. Before going into details, let's start from the problem that we had. As I mentioned earlier, every day we collect around 11 terabytes of raw data and we keep them in different storages, like S3 buckets, MS SQL and MySQL. Some of them are stored on the HDFS cluster and so on. We have more than 200 developers and data analytics working with this data inside the company, I mean. So at one point of time, a problem appeared. Our data developers, they are writing scripts in SQL or Python to process this data. And they wanted to convert those scripts into jobs, scheduled jobs that should run automatically according to some schedule, starting from once per day to several times per hour. And we came up with a list of requirements for this project that we had to build. Since we're storing the data in distributed storages, we need some scheduler application that can work with different storages. There are several solutions for that, like Uzi or Airflow, and our project should be independent from their solutions. So we could use one of that options. Since scheduling application is an external application, there will be a need to deploy the job into this app. So we decided to automate the deployment. Such approach will reduce the amount of work for our data devs and also will reduce the amount of errors. Because to deploy a job, you need to create a certain config files, place them somewhere, turn them on in this application and so on. So we thought of removing this manual work and doing it automatically. Another point is that we wanted to have a change history for our jobs. We also wanted to keep track of versions of what was changed, to see the differences, to be able to switch to previous versions and so on. Besides that, we also decided to have a review and approve process. So when the data developer write a script, write a job, then he will need to send it to review by the manager, and the manager will approve it, and the job will be deployed and up and running. And of course, the last but not the least is the simple and intuitive UI. You know that working with fancy applications is easier and more reliable, something like that. So let's talk a little bit about the application. We've developed a project that fits all our requirements and solves of all our needs. Let's take a look at the higher level architecture. And later on, of course, I will dig into more details. The project is built using two not commonly used design patterns, CQRS and Event Sourcing. You know that the more commonly used patterns are MVC or MVP or something like that for web applications, I mean. We've done our own implementation of these patterns, I mean the CQRS and Event Sourcing. Client, basically the client is the UI, sends commands to the application server. And the application server receives those commands, handles them, and produce some events. And based on that events, we have some business logic inside. And we've also implemented the permissions based on these commands. Some users are not allowed to send some commands. Basically, they can send, but the application server will check if this user can send this event. And a little bit later, I will show you how it looks in the app. So let's talk a little bit about the design patterns. So as I said before, we used CQRS and Event Sourcing to implement the application, to develop our application. CQRS stands for the Command and Query Responsibility Segregation. This pattern was introduced not so long ago. It was done in 2006 by Greg Young, and he did a small presentation on a conference, domain-driven design conference. And also on that conference, he presented his event sourcing, but I'll talk a little bit later about it. And I was watching one of his presentations, later presentation, and he was remembering one funny situation with the CQRS and his presentation. I don't remember exactly was it before the presentation or after, but he Googled himself with the CQRS, like Greg Young CQRS. And at that time, Google didn't know anything about the CQRS, so Google fixed the CQRS to cars, Greg Young cars. And it turned out that in some central states in the US, there is a car dealer called Greg Young Cars. So he thought that it was really funny to see the reaction of the owners of that car center when they received a lot of new visitors without spending any money into the advertisements or something like that. Yeah, right now, if you Google CQRS, everything is working. You can find links to the Microsoft website, to Martin Fowler website, with the description of this pattern. Okay, so as I mentioned before, CQRS is a separation between read and write processes. In most cases, we use MVC, if you remember, design pattern to develop the web app. It's a common approach. There we have DTOs, data transfer objects that are passed through HTTP to the application, and DAOs, data access objects that are used to communicate with DB, with database. And in the application, there is a conversion between DTO and DAO all the time. When you send some entity to the application or when you try to receive some entity from the application. In CQRS, write and read processes are separated. The right part you can see on the slide. Client or UI sends a command, and this command is handled on the server side. By the way, this example also includes the event sourcing pattern, where command produces event and the event is stored in the database. You can see it on the GIF. The read flow is the another side of the pattern, and it's a query. And as you can see, there is no conversion between DAOs and DTOs. When the client does the query, it sends just the query to the application, and the application sends the view, which is pre-calculated on the server side. So it really works well. Also, CQRS provides other pros like performance, scalability, and other stuff. But that's not the topic of our presentation. If you want, you can dig into the more details on the theoretical articles. Event sourcing is the other design pattern that we used in our implementation. The main idea of this pattern is that business logic in the app works based on the events. This design pattern is used a lot in microservices architecture. Maybe you heard of Kafka or something like that. When separated services communicates between each other using events. One services they called producers, they create events and send them to some event bus. And there are also consumers, the other services that they consume the events and trigger some business logic inside the services according to these events. Event sourcing also was introduced by Greg Young, I think in the same year in 2006, the creative guy. Later, this design pattern was described well by Martin Fowler in his book, Design Patterns of Enterprise Applications, as far as I remember. Also, there is an article about it on his website. We all get used to a situation that we have a state for our business entities. Business logic updates the state of our entities all the time, updates, save, delete, or something like that. And it can be a problem to view the state of the entity at some certain point of time. Opposite to this approach, event sourcing provides an audit log of changes for the entity. So you can get the current state of the entity, applying all the events that happen to this entity. And there are, of course, more things in this pattern. You can read it more in Fowler's article. Okay, so the more interesting part, the more interesting stuff, the description how we've implemented these patterns in our applications. Let's dig into the details. Let's view what we have there. Imagine that you are a data developer and you need to create a new job. Here you have a fancy web application with a great looking form, nothing special, just a regular web form with several fields that you need to fill. It looks like any other web application that we used to. So after filling all the required data, we click the create job. And usually we think that at this point, there is an entity sent to the application, but no, it would be true for the MVC pattern, but not for the CQRS. In CQRS, client sends a request with the command inside, not the entity. The command contains details of what happened on an application server, of what happened, yes. And on the application server side, this command will be handled and several events will be fired. Those events will be stored in the database. And okay, the job is created. Now I need to continue working on the job. So I have another form or another page. And this is the UI where I can write a query. For this particular example, I chose SQL. Also, I can specify the scheduling, dependency, edit some labels, specify the action, and so on. And for me, for the data developer or a user of this application, this is just a usual web app. But internally, we can see that something else happens. the client sends another list of commands to the server, like update the job, update the language, update the description, update the action, update the scheduling. Every command fires an event. And later, applying all the events one by one, we can get the current state of a job. So I finished my work on a job, and now I want my job to start working on a scheduled basis. For example, I specified it should run daily at 2 p.m. First thing, I need to approve my job, and here you can see that I can ask some approver to approve it, and I can write some message, and I can request the review. And again, the client sends a command to the server. This command produces several events already. One event marks the job that it is in review state. Another event states that it's a pending. Another event sends the message to the approver and asks for approve, and so on. So one command produces several events. And okay, as an approver, I can review what was changed in the job. Since I'm a developer, I'm a worker, and I'm an approver, really convenient. Since we have events with changes, we can compare fields and return the difference, what was changed, so I can see it in the review. Also, you probably noticed one thing, a button which is called Approve and Deploy. From client side, clicking on the button will approve the job. Of course, it will have the state approved, and it will also be deployed, but you will get only just a notification that the job is deployed. So everything is hidden internally. And again, internally, another command is sent. Everything is, the client sends only the commands. And basically this command will do several things. Again, via the events, and those events will fire another commands. So first, the change of the job will, the state of the job will be changed from waiting for approval to approved. Then the job will be, from the job there will be a production version done. It's like a small snapshot. I will cover it later a little bit. And also the job will be marked for deployment. This event marked for deployment will trigger another command. It's in another internal process, starts to handle it, the deployment process. At the end, the client or the user will see the notification that job is deployed. And the last event will also happen. It will be something like deployment successful. So the commands produces the events all the time. So as you could see from the flow, every action on the client sends a command to the app. On the app, on the application server side, every command produces an event. And these events are stored in the database. And when we need to get the job current, we get all the events for this job and then apply them one by one. So in the end, somewhere here, we will get the current state of a job. Nice. The picture is not shown. We also have the history of job runs, which is really convenient. I don't know what happened to the image. It was there and I didn't change anything. But on the history, we also see when the job was run, which version of job was running, what was the results. If there is a problem, then there is a link to the details, and so on and so on. It is really convenient. Everything in one place. You have the settings, you have the script, and you have the history. Sorry, something happened. Maybe later after the presentation, I will add again the picture and you will see it after the broadcast. Okay, so returning back to Greg Young, and on one conference, he said that CQRS and Event Sourcing is not on a design pattern like we used to it. It's more like the guideline than strict rules. So we also followed these guidelines and we did some our implementations. As I mentioned before, after a job is approved, we have several processes happening inside. You remember it on the screen. And to implement it, we decided to split our commands into two types, external commands and internal commands. External commands, that's the commands that user can send from the client. Most of the existing commands in the application are external. And internal commands, they are triggered according to some events. For example, after approved job, the job is marked for deployment. And at this stage, internal commands started to act. Command something like deploy job. And every command also produce some event. And we have a few of such internal commands. So we also decided to split our events into two, let's call it categories. One category is non-altering production. One type of events is not non-altering production events. You remember the flow and you remember that you need to approve the job after some change. But what if you need to change the description or the name or the README? These changes, they do not affect the job runs. They do not affect what's triggering or what's going on inside the job. So that's why we decided to apply those changes without approval. And on the other hand, we have altering production events. Those events, of course, affects the job run. I mean, if you change the scheduling or if you change dependency or the script itself, it changes the run of the job. So it should be reviewed and approved. Since we did our own implementation of event sourcing and we had a requirement to have a job versions. And as you could see here, by the way, yeah, let's get back a little bit to the slide. Here you can see a run history that I was talking about. Here you can see several things, interesting things. First, the revisions. That's the versions of the jobs that were running previously. We have the information about the run. If there is a problem, you can click on the more info link and open it and investigate it. The duration, the runtime, and so on. So these revisions, they are the versions of the job, and we decided to have a separate table with a pointer to a certain job event, something like, for example, job event 21, it will be the deployment succeeded. So this is the first production version. And this pointer is a mark stating that all events until this event belongs to one revision. The next revision will include more events, the next events, and to the next such pointer. So really convenient. And the most recent challenge that we had was to integrate an RPC into our project. As you remember at the beginning, I said that we have more than 200 data developers working with our data. They're doing a lot of jobs. And for some tasks, we had a feature request to create an RPC. So it will be easier for our data developers to create such jobs programmatically. So we decided to implement RPC for these purposes. But, and we also decided to provide a regular CRUD operations, CRUD interface for our devs, like create, read, update, delete, without all these commands, events, and so on. It will just complicate their work. And so the main challenge here was to do everything carefully. You remember that in a regular CRUD application, we receive an entity with some state. And we had to take this state, separate all the fields, and convert the state to the commands, and send then the commands to the application. Also, there are other, of course, challenges. They're not stated here, but it usually they appear usually in our day-to-day work, because usually it happens with the development and refactoring process. CQRS and Event Sourcing, it's not a commonly used application, design patterning application, so it usually takes time how to solve a feature request or some issue in this approach, not just, okay, I will change the state and everything will be working. So basically that's it. Thanks for attention. I'm sorry for the technical issues. And if you have any questions, I would really love to answer them.